This is joint work with Jenny, Allison, Kapil, and advisors Darren and Houchi. I present to you Cerebro, a computational platform for facilitating opportunistic interactions to connect people across distance. A fundamental research question is it possible to have shared experiences with once co-located, now distant ties? You can imagine college students in close proximity to one another, but after graduating, how do these people actually maintain those ties or maintain this type of closeness that they once had? In today's world, it's easy to post and view updates through social media platforms like Facebook, Instagram, Snapchat, but these types of interactions are more passive, and it's harder to be sharing kind of direct communication with one another. In the other instance, people could do types of direct communication like video calls with each other, but to set these up, it's effortful to initiate. And for someone you haven't reached out to in a while, it's quite difficult even to do that type of initiation and communication to even get to a video call. What we're proposing is, would it be possible to kind of be able to share experiences at opportune moments? These opportunistic interactions are easy to think about in a co-located setting. Two friends might bump into each other at the gym and share a workout or exchange high fives. In the office, it's easy to bump into coworkers over sharing a cup of coffee and catch up over the next couple minutes. What we present is opportunistic collective experiences, programs that facilitate opportunistic interactions between people across distance and time. I think it'll be helpful to show you an example. So these are two users who happen to be drinking, one in Chicago with his beer and another drinking her tea in Taiwan, and finding opportunities where people are doing the same activity could be a great way, we propose in this work, to find kind of shared commonality in people's experiences so that they can share photos, engage and interact easily when their experiences align. In this case, users who might be at these places will get pinged. The interaction model is getting notified on your phone and interacting with people in your physical environment. People participate. The interaction model we're envisioning is participating in opportune moments by kind of detecting those opportune moments through some of the context of your phone, notifying you when you've entered a situation where you might be able to participate, coordinating these interactional opportunities between two people or multiple people, and sourcing people's interactions through pictures, text, photos, and combining it into a digital artifact that everyone can engage and reflect on. Now, in this work we've been thinking a lot about how one might design for shared experiences in opportunistic moments at distance. And the two design principles we're drawing from come from co-located interactions, where it's been shown that having shared experiences and shared goals are really helpful to developing social closeness, feeling more like a group, and increasing social capital. Now, these shared experiences at distance, where we've envisioned for opportunistic interactions to look like connecting people who are doing similar activities in similar situations, but all across the distributed context. In this first photo to your right, 3 people are slurping noodles, all in different cities, but being able to participate in a ramen slurping contest together, despite their distance. In another case, we could imagine leveraging people's unique context and asking people to contribute in their local situation to like a shared digital artifact, whether it be a collage or a combined half-half photo. This would help reflect the differences and similarities in people's local situations, giving people a way to achieve kind of collective goals. And all of these commonalities are brought about opportunistically in the daily situations people encounter. To enact these two principles, shared experiences and shared goals, we have 4 interactional structures that we've envisioned for this computational platform. One is this shared context at the same time. This is like the bumped T example that we presented earlier. In shared context across time, it's often the case that maybe people might share their context, like a view of the sunset, but at different times of the day, depending on their time zone. It's still important to highlight these types of shared contexts, even if people aren't doing the same exact thing at the exact same moment. We can imagine, too, that in leveraging people's unique contributions in their local situations to contribute to a shared goal. A shared goal might be creating a collage of parkour maneuvers in different environments, like jumping over benches and swinging over trees or jumping over puddles. These types of active scenarios could happen in all sorts of local situations, and depending on users' local situations, they could participate. And finally, building towards we envision building on others' participation as another way to work towards a shared goal, like creating a shared storybook, in which users take photos of their physical environments and get to caption and add their own spin of the story. Now, to enable these APIs, these 4 interaction structures, our focus is on describing the fundamentals of these interaction structures through a programmatic API. And that'll allow us to imagine whole bunches of opportunistic interactions and to be able to prototype and design in this space. This API leaves the low-level coordination of when people enter these situations and how they participate to a system model that underlies this API. A fundamental construct is the idea of needs in the API. In this example, we're describing the bumped example where people are drinking tea. We describe a situation which has a context detector called drinking. That context detector operates for 2 people at the same time, and only when 2 people are drinking at the same time will this context detector trigger. When it does trigger, we pass to users a template of what they should see when they participate. After their participation is gathered, this need is completed when 2 people have submitted. This gives a participation structure similar to other crowd programming languages, but allows us to operate on these changing situations. Another core construct is callbacks, allowing multiple contributions to be able to build on top of each other. In this example, we were thinking about the storybook example, in which after one person submits a need for, imagine a user is telling a story about a Harry Potter story, and one scene in the story illustrates Harry Potter in a thunderous a thunderstorm outside when it's really cloudy. Well, given that sentence, this callback would be able to produce a new need that looks for people who are in situations where it is thunderstorming and cloudy to kind of participate and add their picture to this story. Now, with this API comes an opportunistic engine that powers that powers this API and allows people to allows participants to be able to starting over. Opportunistic coordination engine is the backend that empowers this API. It tracks users' context and recognizes these interactional opportunities. Second, it enables users to participate at opportune moments throughout their day by recognizing these opportunistic interactions across people. It does this by monitoring, coordinating, and progressing these interactions as people fall into situations and participate and progress the interactions forward. Now, this system model this quarter was especially studied, but I won't have time to talk about it today. But we studied particularly how to, in a field deployment, how does this system model, I'll go back, how does the system model really identify users and their contexts, and how does it notify when people have that situation and decommission them when they don't. I don't have those. I won't detail the new revised system arguments for that work today. Now, we've run some exploratory user studies where people have been geographically distributed, and we've seen how people are able to use and engage in these types of intimate shared experiences at distance. And it gives us promise that first, that people can have these personal interactions during convenient moments in their day. But second, we're really interested in a second outcome too, which is lowering the barriers to initiating contact in the first place. If you remember, co-located friends, once co-located, now distant friends, might not have all the commonalities they once had in college to be able to check up on each other or engage. And our hypothesis is that these commonalities that are automatically identified through common shared experiences or setting up shared goals gives enough to break the ice between people who might have not frequently contact each other, or people who have more anxiety and see personal barriers to even directly messaging someone to catch up. And these are types of things we want to be able to explore in future user studies. And I think the core takeaway for us is to really understand the differences between how interactions on Cerebro, our system, but more generally, how OCEs can provide low effort ways to actively connect with others across distance and time, and how these types of interactions are fill a different niche than the types of social media platforms or more effortful ways of directly communicating, like video call, text messaging, or sustaining long conversations. So I think we'd like to end with trying as a conceptual approach to thinking about how we could actually fit directly engaging interactions into people's busy lives despite distance and time. Thank you. A lot of these slides were inspired by work with Jenny and her presentation at Kai. So thanks.